sketching recip functions. I decided I would go demon mode and put one of the hardest sketching questions they can ever ask you guys. Sketch y equals 3 plus 2 sec theta plus pi over 3 in the interval between minus 2 pi and pi. Include any asymptotes and label the coordinates of the turning points. Trust me, you're going to want some popcorn for this one. Sit back, relax. Maybe you want to write down some notes, I don't know. But it's going to be valuable to your learning, all right? So, how do we sketch these types of functions? First thing is the range. Now, I introduced you guys to this when we did radians. When I did the intro to radians, if you've not seen it yet, go back and check it out. But the first thing I said is that you should modify the range even when solving and figure out the part of the graph you want to move to the left by pi over 3, because theta plus pi over 3 moves the graph to the left. You don't want to draw too much, okay? So only draw part of the graph that you are then going to shift to the left by pi over 3, so it fits within this range perfectly. So to do that, we're going to have to modify the range. Okay, modifying the range, we're going to add pi over 3 to all of these values. That I'm going to get minus 5 pi over 3. Then I have theta plus pi over 3. And then I have 4 pi over 3. Now, am I expecting you to know what the cosine graph, the sec graph looks like? No. So let's sketch it again. I'm going to do it based on observation of the cos graph. So the cos graph between minus 2 pi and 2 pi. Now, first things first is looking at the original range, we added 5 pi, added pi over 3. So 5 pi over 3 might be, or minus 5 pi over 3 might be over here. Now, cos of minus 5 pi over 3 is the same as cos of 5 pi over 3, which is a half. So I'm basically up to here. So this point here is minus 5 over 3 pi and 1/2. And that's my half there. And 4 pi over 3, here's pi. So when I add 4 pi over 3, I'm here, which then takes me to minus 1/2. And you guys can obviously type that in your calculator to confirm. So this point here is 4 pi over 3 minus 1/2. So this is the only part of the graph that we need to focus on. So let's draw the sec graph between that range as well. Now, the first thing you should always focus on is reciprocating 0. So when that's 0, that 0, and that 0, because that is where my asymptotes are going to be. 1 over 0 is undefined. So I always try and line up everything. Okay? Now this would have been at negative 270 degrees for the cosine graph, which is negative 3 pi over 2. This here at minus pi over 2, theta is minus pi over 2. And this here would have been at pi over 2 as well. Now between these two zeros is one full arc. So we're going to get the same thing here. We're going to get one full arc. Okay? Remember, it looks like a parabola. So this here is going to be at minus 1, yeah, because this is at minus 1. Then here we have one full arc. We're going to get one full arc as well. This time just at 1 though. Okay, we're going to have to keep an eye, because they said keep an eye on the coordinates of the turning points as well. So this turning point here, that's at minus pi. So here we have minus pi 1. And this is at 0, 1. Okay? To be honest, it's probably better to look at it like that rather than indicate those. Okay, so let's figure out, what's going on here. Now this is at minus 5 pi over 3.5. When you reciprocate a half, you get 2. So that's over here. It's going to be above. Yeah, and that's at my minus 5 over 3 pi. Okay. Now this is gradually getting smaller. So when you reciprocate that, it's going to get bigger. Okay, so it's going to go up. Like that. Then over here, it's kind of like nearly a full arc. Yeah, nearly a full one. But, not quite there yet. So it's going to be nearly a full one like this, but not quite. So we definitely have half. Yeah, so remember this here is at pi and minus 1. So it's definitely going to come up like this, half of it. where this is at pi and minus 1. That should say minus. But then, this 4 pi over 3 minus half, when you reciprocate that, it's going to get down to minus 2. So that being minus 1, minus 2 maybe here. So it's going to come down and stop. So this here is 4 pi over 3 and minus 2. All right? So that is the part of the set graph that I'm going to be moving back by pi over 3. All right? Now, essentially what's happening is that plus pi over 3 is actually talking about the y-axis. You're just adding pi over 3 to the whole y-axis. So it would basically look like this. So the y-axis is now here. And by me moving the y-axis, I can basically like copy and paste this stuff if I want to. Maybe I moved it a bit too much there. So I'm giving you guys as many tricks as I can to not have to think too much here. So I'm going to kind of shift it off center. So here. On the camera, it should look much nicer. And I'm literally just copying and pasting all of this. Okay. Then here we have that kind of half flick up at 2. This monitor this. So that y value is at minus 2. Then here we have that full wave. Here, we're just copying and pasting it downwards. The turning point is going to be slightly to the left. But it needs to come further down than the other point, which was at 2, right? So it needs to come further down. Look like that. And then we have this kind of full, but kind of like half as well. Like that. Okay? Now, one thing I know for sure is that this, when we minus pi over 3, is going to be at minus 2 pi 2. Yeah, the y value did not change there. And then this minus 3 over 2 pi, we need to do that for the asymptotes. Minus 3 over 2 minus, so minus 1.5 minus a third is minus 11 over 6 pi. Then over here at minus a half, minus a third is minus 5 over 6 pi. Now I know here a half minus pi over 6. A half minus a third is pi over 6, so 6 pi. So here at minus pi, that turning point when we minus pi over 3 is minus 4/3 pi. And minus 1. This here was at 0, but we're now going minus pi over 3 and 1. This point here is at, what would that be? That'll be at 2/3 pi now. And why did I write, yeah, minus 1. What am I doing? I'm bugging. Then this, when you minus, is going to take us back to pi. And there you go. There's the sec graph between minus 2 pi and pi. The next thing we need to address is this 2. Now that 2 is literally just going to multiply all my y values by 2. And in the exam, I would literally just change this. I'd write over it. But since I have the benefit of rubbing things out, I'm just going to double everything like this. Okay. And then we get to the last part, which is to add 3. Now, when we add 3 here, we have to be very careful because really these bits don't change. So 4 is going to go to 7. That's going to go to 5. But these 2 points are going to go above the x-axis slightly to 1. Okay. So let's do that. So I don't need these bits anymore. The next graph we're going to draw is the final graph. So I'm going to try and line things up. I'm basically, at 3, I'm basically moving the x-axis down. So I'm So I'm going to move it down slightly. All of these bits, they're not changing. The asymptotes. What is that? Theta is 1/6 pi. Theta is minus 5/6 pi. And theta is minus 11/6 pi. So we have this point here, which I'm going to do quite high, is at minus 2 pi and 7. Now this is only going to go up slightly above to 1. So minus 4/3 pi 1. Then we're going to have that full wave. Then this point here is going to go up to 5, which is basically, well, it's closer to here, right? So, like here. Then it's going to go up. Now, one thing would be useful for us is to actually know where this point is. That was in this bit here. When you sub in 0, you get sec of pi over 3, which is 2 times 2, 4, which is actually lining up with this. So it actually crosses the y-axis here, the same level as that 7, and that looks atrocious. Okay, hopefully you guys will forgive me there. So that there is 7. This here is minus pi over 3. And what do? We moved it up by 3, so 5. And then finally, we have that this is going to go up slightly above to 1. So that's going to be 2/3 pi and 1. So it's going to come up here. But then that minus 4 is actually going to go down to minus 1. So it's actually going to come slightly below and then stop. So we get pi and minus 1. And that is our graph between minus 2 pi and pi. And that is an absolute horror of a question. But the game's the game, innit? Part B is nice and easy though. Hence deduce the maximum minimum value of this. So basically talking about these turning points essentially. Okay? So just think back to GCSE. When we do bounds and we do maximum, minimum, upper, lower bound stuff, you're thinking about the fraction. I'm going to call it f of x. If you want f to be as big as possible, and you're doing 1 divided by, do you want the numerator to be as big or as small as possible? Well, you want to do 1 divided by small. 1 divided by small makes it big. So you want this to be as small as possible. Okay? Now, what's the smallest value sec can be? Well, think about the cosine graph. The smallest cos can be, so the smallest cos can be, so remember cos is between 1 and minus 1, right? So the smallest cos can be is minus 1. So the smallest sec can be is minus 1, yeah? And here we're referring to the turning points, okay? So all of this is referring to the turning points. Obviously, sec can go down to negative infinity, but this question specifically is referring to the turning points. Maybe I can specify that, okay? So minus 1. So here, the maximum turning point will be at 1 over 3 plus 2 lots of minus 1. 3 plus 2 lots of minus 1, which is just 1. Okay? And then, for the next part, the minimum of x, we have 1 over big, which, considering the same thing, is when the cos graph is 1, sec is 1 over 1, so nothing changes there. It will be 1 over 3 plus 2 times 1, which is 1/5. Okay? And that makes sense in terms of this. When we reciprocate, you see the turning points here are at when y is 1. 1 over 1 is 1. Here the other turning point at 5. 1 over 5 is a fifth. And those are those answers. But yeah, guys, part A was hella crazy, all right? That would be like 5, 6, potentially 7 marks in the exam because there's a lot of stuff you need to consider there. Part B, 2, maybe 3 marks if they're feeling good, which if they give you part A, they're probably not feeling good. But anyway, guys, if you learned something today, I would appreciate if you hit the like button, subscribe for more maths content. If you want to learn more about my maths courses, link is in the description. And you could join the Lung Gang Reddit page if you want to submit your own questions. I'll see you in the next video. Nice.